It makes sense. Not always. Not always. The first question I want to answer is, why do we use inequalities? Why do we use inequalities is the first question I want to talk about today. They are used for a range of answers. They are used when there is more than one answer, when there are more than one possibility. They are used when there are multiple answers. Used to describe multiple answers. Let me give you an example. If I were to ask the question, how many of you in this room are 14 or less? Please raise your hand. If you're 14 or less, please raise your hand. Good. Put your hands down, please. What that is something like this. Your age is less than or equal to 14 for the people whose hands were raised. I didn't ask how old you were. I didn't ask if you were 14 or 13 or 12 or 11. I didn't ask how, but this describes all the ages that would qualify you if you were 14 or less. And if we were to graph that, it would look like this. I'm not a person who likes to write out all the numbers if I'm going to 14. I'm not going to go and write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Instead, I'm just going to put 14 right here in the middle. And usually I will pick a bigger number, like 15, to the right of it. And I'll pick a smaller number, like 13, to the left of it. And if I was to graph the ages that are less than 14, less than or equal to 14, I would put a closed circle over 14. And I would have an arrow that goes this way saying all these ages this way are less than or equal to 14. Does that make sense to you? If I said you have to be less than 14 to raise your hand, how many of you are less than 14? Raise your hand. Only 1, 2, 3. 3 are less than 14. That means they have not had their birthday yet, right? We would use an open circle. So I want you to do a little side note over here when we go to graph. Graphing. I'm going to put graphing right here, and then I'll put a little bar right there underneath it. When we do this way, less than. When I do greater than, it is an open circle. Let me make sure you can read that. Nope, can't read it, so I'm going to scoot it over a little bit. When I'm graphing, if I have less than or greater than, it's an open circle. It looks like this in the graph. If I have less than or equal to or greater than or equal to, we used a closed circle. That's just a reminder. It looks like this, a filled in dot. It means the value that's below it can be included in the answers when it's closed. 14 is a possible solution for this particular problem. A lot of times in real life we use this for eligible to vote. You have to be a certain age to vote. You can start voting for elections and propositions as soon as you are greater than or equal to what? 18. Oh, 18, you all know. You can start driving a car if you pass the driver's test when you are greater than or equal to what?
16.
Oh, you know these ages. See, and it doesn't matter what the age is. It just that's how we use inequalities in real life. That's the first thing I wanted to say. The second thing I want to say, if you see this, I'm going to come back over here, and it looks like an L. It's the one that looks like an L. I want you to remember that as less than. Look how I did that. I did a less than symbol and I wrote less than. Because when you see it, you should be able to read it as less than. If I see this with the bar underneath it, it reads less than or equal to. The opposite of the L is greater than. And then, of course, we have greater than or equal to. Greater than or equal to. So let's do an example like number 3 on your worksheet. Number 3 says negative 2 plus 2p is less than or equal to negative 14. Negative 2 plus 2p is less than or equal to negative 14. And I'm going to call on a couple of you to help me do this problem. Michaela, would you tell me what would you move first? This Mick. Yeah, this Mick. Sorry. Wrong. Yeah, Michaela. Yeah, Mick. Sorry. What would you get rid of first?
Take the negative 2 and add to negative 14.
Do I just add 2 here? Where else?
And to the negative 14.
Good. We draw a line. And when you put that together, tell me what you would write.
Negative 12.
Wait, what about this side?
2p.
And then what is this called?
Less than.
No. What is this?
2 less than or equal to.
Very good. And what you said this was?
Negative 12.
Good. Let me have you stop right there. What I asked her to do was to tell me what to do, and she had to tell me what this was. That's important. Less than or equal to, and the negative 12. Seeing. What did you do next? Did she not hear me?
What?
Seeing. What do you do next?
Divide by 2
Divide by 2. And what do you get, Cian?
You get negative 6.
Okay, you got negative 6 over here, but what do I write over on this side and what do I write in the middle?
Less than or equal to negative 6.
Good. That's our answer. That's how we do these problems. And this is a basic problem. So far, so good. The inequality, I'm going to put a little note off to the side here. The inequality always faces the same direction. The inequality always faces the same direction. Unless, and I'm just going to put a little colon right there. The inequality always faces the same direction unless, because there's two things where the inequality would change direction. And I'll show you what it is in just a second. See how this inequality stays the same direction, same direction, same direction? The inequality always faces the same direction unless two things happen. So I'm going to show you the first example. Let me show you an example with some basic numbers. My favorite numbers right now are 3 and negative 15. Okay? My room number is room 315. So I always try to incorporate the numbers 3 and 15 in my problems just because when I make them up, they're easy and I remember the numbers of what room I'm in. I bet you if you ask your other teachers what room are they in, they probably forget too. Okay? Which one is greater, the 3 or the negative 15? What symbol would I use in between these two things? Greater than or equal to? Greater than. Just like that. You agree? Very, very basic. 3 is greater than negative 15. 3 is bigger than a negative number. I agree. What happens if I switch sides? If I switch the 3 to this side and I switch the negative 15 to this side. Negative 15 into 3. Now which symbol would I use? We would use a less than symbol. If we switch sides, then the inequality flips. If we switch sides, then the inequality. Here's what I mean by that. If I move the 3 to the right side and I move the negative 15 to the left side, the mouth is eating the 3. The mouth still needs to eat the 3. And that's important because sometimes we're going to have 15 is less than x. And I don't want you to keep your answers with x's on the right hand side. I want your answers to have x's on the left hand side. So if I move the x over on the left side and I move the 15 to the right side, what inequality symbol do I need to use right here? Greater than. If I move the variable to the left and the number to the right, this inequality, the mouth is eating the x, the mouth still needs to eat the x. I always want your variables on the left. Variables on the left. So, stipulation number 1. The inequalities always faces the same direction unless we're moving the variable to the opposite side, and unless we're flipping the variable around. The inequality always faces the same direction unless we're flipping the variable to the other side. Or. Let's use that 3 and the negative 15 again. I'm going to put it down right here. 3 is greater than negative 15. But I'm going to now divide and divide, and I'm going to divide by negative 1. Divide by negative 1. Okay? Let's do that math real quick. 3 divided by negative 1 is negative 15 divided by negative 1 is Which one is greater, negative 3 or 15? If we divide by a negative, this inequality has to switch directions. Otherwise, it is no longer true. Otherwise, it would no longer be true. Anytime we're working a problem, if we multiply or divide by a negative, we have to flip the inequality symbol. That's our other way that the inequality stays the same direction unless, let me underline unless, 1, we flip the variable to the other side, or 2, we divide by multiply or divide by a negative. Unless we multiply or divide by a negative, then we're going to have to flip it. Change direction. I'll show you what I mean. Let's do example number 8. Example number 4. I lied. 4. 12 is greater than 60 minus 6t. Let me scooch this up a little more on the screen. What I'm going to do is call on a few of you to help me. So, Allie, help me out. What's the first thing you would do?
Take subtract the 12 from 12 and under 60.
So subtract 12?
Yeah.
Subtract 12? I would not do that. I want to get the t by itself. I want to try to get rid of something else. Lexi, what would you get rid of?
Can I divide the 6 so I can get the variable by itself?
I do not recommend that either. Wait, that brings me to a point. What should we always try to get rid of? We should always try to get rid of, let me write that off to the side here because I need a reminder. Always get rid of addition. Somebody needs to turn their ringer off. Always get rid of addition and subtraction first. That means for Allie and for Lexi, if I have the t and 6 is multiplying the t, I don't want to get rid of that, but I need to look at what's on the same side as the t that I can get rid of, something that's being added or subtracted to it. What are we going to get rid of, Blake?
60, but we're going to do negative 60 on the bottom, and then do minus 60 from the top.
That's what we want to try to get rid of. Does that make sense? Okay, so now, going back, what do I get? Lexi, tell me what I would get if I did 12 minus 60. If it's a number that you need a calculator for, don't be afraid to get the calculator out.
So it would be 48, and then there would be the sign.
Let me see. 12 minus 60 is, are there more negatives or positives?
Negative 48.
Negative 48. Then you said what?
And then it would be the greater sign, and then it would be negative 16.
I agree. Going back to Allie. Now what would we do? We want to get the t by itself, Allie. So what are you going to do next?
Add the 16.
No. What is this negative 6 doing to the t? It is multiplying it. What's the opposite of multiplying, Allie?
Divide.
So I want to divide by.
6.
Do you want to get rid of that negative too?
Yeah.
So let's divide not just by a positive 6, divide by a negative 6, please. To both sides. Divide 6, divide by 6. What What is negative 48 divided by negative 6?
8.
When I divide by a negative, put a little star right here, something happens. Something is supposed to happen when I divide an inequality by a negative. Don't tell me, tell the person you're sitting next to what's supposed to happen. I heard lots of right answers. Very good. So what goes here? Use the right words for it. What are the words that describe what goes right here? Which one? Say it out loud, Miss Knowles. Agreed. And then we have T. You have it? 8 is less than T because I had to flip the inequality symbol. Do I want your answers on the right side? No. I actually want your variables on the left, and I want your number on the right when you get to the final answer. So which symbol should I use now in between these two things?
You flipped it.
What?
You flipped it.
Wait, hang on.
You flipped it already.
The T, I divided by a negative, yes?
No, look.
Okay, I divided this, so I had to flip the sign. You're good with that so far?
Yeah.
Okay, now I do not want my variable to be on the right side. I'm going to want it on the left, and I want the number to the right. Earlier, we talked about if I have a number and a variable on the right-hand side, if I move it this way, what do I have to do with the symbol in between? That's what I'm talking about. So what should I have here? That's what I want. Now here's the reason why we're doing that, okay? In this problem, the T was on the right-hand side. If you solve it and you get to this, this is an okay answer. 8 is less than T means the exact same thing as T is greater than 8. But if you have the variable on the left, if you go to graph this, I'm going to put an 8 right here and a 9, and I'm going to put a 7. T is greater than 8. That means that I can use an open circle and everything to the right of T would work. And it's important because now, if the variable's on the left, the arrow, see how it points to the right? The graph is going to point to the right. It will always match. The graph will always match the direction only if the variable is on the left. But if you leave it over here, then it might be in the opposite direction. So that's why I want you to get used to keeping that variable on the left in your final answer. I want you to do that extra step. And on the worksheet today, there's not a lot of graphing, but on the quiz today, you have to graph every single inequality. So I want you to get used to that as well. I have one more example. And then I'm going to take a little break, and then I'm going to talk to you about the trick questions in the next set of notes. But we'll do it. Here's the last example, and then I'm going to let you try a few problems. 22 is greater than, you can't see that, so let me slide it over. 22 is greater than or equal to 5 times the quantity of y minus 2 minus 3y. I like this one because it really reminds me of what we've learned in 1.3. Let me have Grace help me out. What's the first thing you would do, Grace?
Times the 5 by the y and then
What's that called?
distribute.
Thank you. I like how you use the fancy word there. So tell me what you would get.
5y and -10.
And then what do you do with this and what do you do with that and that? Tell me what you're going to do next.
Dump it down.
So what do I write?
-3y
What about over here?
times
I agree. Let me stop you right there. Tyler, what am I going to do next?
Add 10 on both sides.
We can do that. I wouldn't recommend doing that first because if I go back to your 1.3 notes, they say to do something else first and what I recommend. Chris.
Combine like terms?
Combine like terms. Do you know what that means, Tyler? What would you combine? Okay, let's do that next. Let's always try to make it smaller before we move things around. That's what I recommend. What do you get, Tyler? Tell me what else to write. Tell me what else to write.
22 is greater than or equal to.
Good. Thank you, Tyler. Let's see. Trinity, I haven't heard from you. What would you do next?
Add 10 both sides.
What do you get?
32 is greater than or equal to 2y.
I like what you've done so far. Presley, haven't called on you. What would you do next?
Divide the 2y into 32.
So what am I dividing by?
2y.
Do you want to get rid of the y as well?
Or just 2.
We just want to get rid of the 2. We want the y by itself. I agree. Divide by 2. Tell me what you get, Presley.
16.
Tell me what to write.
16.
Gotta know what that, what,
Greater than or equal to
good.
y.
Good. Is this how I want your answer, Melina? No, it is not how I want your answer. So since she doesn't remember, Jaden, you can help her out. How do I want her how do I want all of your answers? The variable on the left. So if I have the variable on the left, what would it be, Jaden?
Y is less than or equal to 16.
Do you agree with Jaden? If we do this, then when we go to graph it, the arrow direction will match the same direction as when we go to graph. That's why we're doing that. Blake has a question though.
In the last example, if you go back,
Yep.
see how in the first part they're facing like this,
Yep.
but then when you wrote your answer 8, you flipped it, and then you flipped it again.
Sometimes you flip things twice. Sometimes you flip it once.
So
The reason why, okay, well here, the reason why this one flipped from here to here is because we divided by a negative. So this has to flip. Then when we switch sides, it has to flip as well. The only times we flip or change directions if we divide or multiply by a negative. We divided by a negative. Now let's go over here. Did I divide by a negative?
No.
So this stayed the same direction.
Oh, yeah.
But if we flip sides, then it has to switch directions. Don't forget that. That's the basics of it. Okay? This is the first part of your notes. There are some trick questions, but we're not going to talk about those just yet. When you get to your worksheet is organized a little bit funky. Okay? The first 4 questions have these boxes, and you're going to look at it and be confused. But don't be confused. Here's what it does. Okay, let's look at number 1 real quick, okay? The first thing that you would do on number 1 is what when you had that problem? Let me ask Katie, I haven't asked her a question today. What would you do first, Katie?
Add 3 to both sides.
Ooh.
Which are we on?
Number 1.
Okay. Then subtract 12 from 24.
You agree? Subtract 12, subtract 12? I would subtract 12. Now here is what they do. They have the 3m plus 12, and then they have this 12 there, and then they have the less than 24, and they have a 12 there. They're basically trying to write out for you, you know what you're going to do first, don't you? And they want you to put in something in this box. What are you going to put in the box? A minus sign. Why are you putting the minus sign here? Because you're subtracting 12 from both sides. They're just having you show your work. If this confuses you, cross it off and just do the problem. Does that make sense to you? Don't feel like you have to use this or this or this or that if you don't want to.